All right, good morning, everyone. It's Miss Summers with your notes on human impact on groundwater. So, yesterday we talked about groundwater, how it is stored. We talked about the difference between porosity, which is the amount of space in soil that can hold water, versus permeability, which is how fast water can move through soil. We talked about the different zones. So the zone of aeration is that top part of the ground where it's not saturated, it's not completely full of water, but it's still permeable. Water can move through it. And then the zone of saturation, which is that layer of the soil that is completely filled with water. Water can freely move through it. That is our aquifer, and that's what we're going to be talking about today. All right, how do people negatively impact this groundwater resource? Okay, so we're going to revisit this quote that our good pal Ben Franklin said. We talked about this the very first day of this unit. We will know the worth of water when the well runs dry. I think the quote I had on Monday was slightly different, but same idea. All right. He's saying that when we run out of something or when we don't have something anymore, we understand how valuable it is. Okay, so again, we can think about something like not necessarily like, the internet or something like that. Like when the Wi-Fi goes out, you're like, gosh, I use the internet for a lot of things. All right, when we run out of a resource like water, that's a bajillion times worse because water is not like Wi-Fi. You need water in order to survive, okay? So how do we mess up this resource? All right, before we do that, in order to understand part of the impact, we have to understand how groundwater moves in and out of the ground, okay? So remember, we have precipitation, okay, rain, snow, whatever. That precipitation infiltrates into your aquifer. Okay, so here's your water table. Okay, this kind of upward little part. All right, here's your aquifer where it's completely saturated, and here's your zone of aeration. All right, infiltration. Okay, this water moving into the ground and percolation, water moving through the ground, takes a super long time. All right. I know we haven't talked about human population yet, all right, but I trust that you can probably already guess. Either you already know this or you can guess by this little diagram. It says human population growth chart throughout history, and it's, not a whole lot of people, pretty steady, and then all of a sudden in the late 1800s and 1900s, it went, yep. All right. That's because of a lot of things. It's because of the advent of modern medicine, industrialization, all that fun stuff. We'll talk about that later on in the year. But basically, there's more people. And if there's more people, you need more stuff. That makes sense, right? Okay, if we were to have, 4,000 students at our high school instead of the 2,000 that we have, we would need more stuff. We would need more desks and more space and more teachers and more paper and all that bananas, okay? So the more people we have, the more water is being used. But if you remember from day one, the water cycle, Earth is a closed system, the amount of water on Earth is not changing. Humans don't affect how much water there is, but we can affect where it's at. So we have the same amount of water, but we got more people using it. That's going to be a problem. All right, so let's look at how we mess stuff up, okay? Humans impact groundwater by overusing it and polluting it. Those are kind of like the two ways that we are harming that resource. All right. So let's take a look at how pollution happens in groundwater. Okay. Pollutants come from the surface into the groundwater by infiltration. Okay, so imagine, it's almost spring when I'm making this video. When it starts to warm up, you might go out in the yard one weekend and put some fertilizer down so that the grass can grow, all that fun stuff. All right, some of that stuff doesn't get absorbed by the plants, okay? The water, when it precipitates, it's going to carry those fertilizers and pesticides and all that gunk, and it's going to bring it down to that aquifer. All right? Here is an article. If you wish to look at this article, you're absolutely welcome to at your leisure. But this is a problem in North Carolina with coal ash. So we talked a little bit about that yesterday. All right, when we were talking about like landfills and man-made ponds and things of that nature. Coal ash is from coal-fired power plants. It's basically the leftover coal that can't be burned anymore, but it still has some stiff in it that you wouldn't necessarily want to be around. Okay, and in certain places, this coal ash has contaminated the groundwater as well as surface water. Okay, so this coal ash, some of it gets picked up by water infiltrating, and now all of a sudden it's in your groundwater. Okay? Pollution can also come from underground sources. Okay, so we store a bunch of stuff underground, primarily, I don't know why I said it, primarily, through things like septic tanks. Okay, so like when you're at your house, and you like flush a toilet or take a shower or whatever, all that water goes to a septic tank. Okay, if you have a septic tank, if this were to like break, okay, as they do over time, all that raw sewage, which is a health hazard, is going to get into your water system. All right, so here's a really fun little article. Again, you can read it at your leisure, but I'll give you kind of the background. These folks up in Michigan, I think, they were using artificial sweeteners to track groundwater pollution. All right, artificial sweeteners are basically sugar molecules with like an extra little chlorine attached to it, and because the little chlorine's attached to it, your body can't break it down like normal sugar, because it's like, that's not sugar, what is that? I don't want that. But your tongue is like, oh, this is just sugar, guys, this is just say sweet. That's why it works. All right, so anyway, so your body's like, well, I'm not going to break this down, so I'm just going to get rid of it. So your body eliminates that, all right, when you go to the bathroom, all right? So artificial sweeteners end up here. Well, what these people in Michigan found, they were looking at different wells, and they were like, wait a minute, there's artificial sweeteners in this well water. And they're like, where did that come from? Because obviously no one's pouring Diet Coke into the well. That would be silly. All right. And what they found is they were tracing it back to damaged septic tanks. So this human waste that had the artificial sweeteners in it were getting out and contaminating the water. So it kind of has kind of gross implications where you're like, ugh. All right. But it's showing us, that's where this contamination can come from. All right. So we can make the water a lower quality. Okay. We can make it hazardous. We can put chemicals or, waste products can end up in that groundwater that we would not want to drink. Okay. The other main problem is overuse. Okay. I said this yesterday to one of my classes. I believe I said this yesterday in one of my classes. An aquifer is like a bank account. Okay. So imagine you have a bank account. And let's just say you start off with this bank account with $5,000, and you're like, oh, that's a lot of money. That's a nice little bit of money, okay? And every day, somebody, some fairy godmother somewhere puts another $50 into the account. And you're like, I could live with that. That would be awesome, right? All right? You start out with a whole bunch of money, and every day somebody adds a little bit. Okay, sounds like a win-win, right? But if you spend $300 a day, it's not going to take very long for that bank account to run out. Even though a little bit is being put in, you're taking out more. Okay? That's just basic economics. If you take out more than you're putting in, you gonna run out. All right? So because infiltration and percolation happen super duper duper slow, all right, aquifers are dropping. All right? There's not as much water in the ground anymore, which means that resource isn't going to be there in the future, and that's a major issue. All right. So we have I'm going to show you this video. I'm just going to show you like the first 3 minutes of it. But it's about the Ogallala Aquifer, which is out in like Texas, Oklahoma, Kansas, Nebraska, that kind of area, that kind of Midwesty part of the United States. And we're going to look at these questions. So how does the aquifer affect agriculture? When do farmers more dependent? When do they need it more? How much recharge occurs in the course of 1 year, and why do we care? Okay, we're going to say no ads. We're going to say no ads. No ads. Sweet. Yay. I got this a wee bit.
In the state of Kansas, agriculture is king. Along with high yields of corn and soybeans, Kansas is the top wheat-producing state in the U.S., with yields of more than 382 million bushels in 2012, according to the USDA. The secret to this land's bounty is not just the soil that covers it, but also something below ground that no one can see: the Ogallala Aquifer, the largest freshwater aquifer in North America.
For decades, you've had incredible production of agricultural crops on top of this, and largely that's because of the incredible water resources that have been available to it.
The Ogallala Aquifer, also known as the High Plains Aquifer, is a groundwater storage reservoir that stretches 174,000 square miles underneath parts of 8 states, from South Dakota to Texas.
This well here is 303 foot deep.
Stan Townsend, a 6th-generation farmer from Weston, Kansas, grows corn, wheat, pinto beans, and peas on his land. Like many farmers, Townsend depends on the aquifer to irrigate his crops, especially during times of extreme drought.
This country is about weather, and right now it's sure not in our favor.
Today's irrigation technology is able to pump out water that has been in the aquifer for hundreds of thousands of years in just a matter of minutes, a rate which far outpaces how fast nature can replenish it, threatening the overall sustainability of the aquifer and agriculture.
This well over on the southwest was right at a 2,000 gallon minute well, and now all we're getting out is about 600.
According to the Kansas Geological Survey, groundwater levels in the aquifer have dropped an average of 14 feet since 1996, about a foot a year. Aquifer drop rates suddenly doubled, an average of 2 feet a year between the start of 2011 and the end of 2012 alone.
Since about 2011, there's been a significant drought, and this is really across most of the High Plains Aquifer, but this area, as well as others, you're now in a period of extreme to exceptional drought.
Dave Heineman, a hydrologist at Michigan State University, is leading a team of scientists funded by the National Science Foundation that is studying the aquifer. The team is analyzing data from as far back as the 1800s on changes in climate, irrigation technology, and water policy to build models that could forecast what the future holds for the aquifer and for farming.
When we feed the climate into these models, we're able to predict what happens with the water levels. And as long as we have pumping data, we really get a great understanding of the system.
One of the reasons why the aquifer replenishes or recharges so slowly is due to the water cycle itself. When precipitation in the form of rain or snow hits the ground, some of it runs off. Some evaporates back into the air from the ground, or is transpiration from plants. What doesn't run off or evaporate slowly seeps down through the soil and its layers by gravity in a process called percolation. In western Kansas, it can take 1 year to recharge the aquifer by less than an inch.
There's not enough recharge out here. Not enough precipitation.
During the drought of 2012, Mitchell Ballman, a 4th-generation farmer outside of Hoxie, Kansas, was able to maintain his crop yields only by pumping more water out of the aquifer.
In 2012, we were drastically impacted. I mean, it affected our crops, definitely affected the aquifer. We depend heavily on the Ogallala, which is what we're pumping up for our pivot irrigation.
Now, in an effort to extend the life of the aquifer, Ballman and other farmers have started a grassroots effort to cut back pumping by 20% over the next 5 years.
I think we're averaging probably 2.1 foot a year is what we're dropping. That's why we're looking ahead to the future to try to promote saving, being proactive instead of reactive.
But sustaining the Ogallala Aquifer and Kansas agriculture must also include more scientific research. Hyman's team is working with local and state government officials, water policy experts, and farmers to develop a long-term model for aquifer water use, based on more precise measurements of precipitation, percolation, and natural recharge, better monitoring of agricultural pumping, and forecasts of changes in climate and population.
All right, so we'll leave it there. So, the Ogallala is necessary. Why is it necessary? How does it affect agriculture? The Midwest is the agricultural capital of the United States, so that water is used in order to produce those agricultural products. When did the farmers need it more? They needed it more during droughts, okay, which makes sense because if you're not getting water from the sky, you get it from the ground, all right? If it's not raining on you, you might as well pull it up out of the ground, okay? But here's the problem. Here's where it's like a bank account. Here's where it's like a bank account. Number 3. If you heard how much recharge happens in the course of 1 year, only 1 inch. That means the aquifer goes up by 1 inch. That water table goes up by 1 inch, all right? Which is a lot of water, okay? But if you heard how much water is being taken out, over 2 feet a year. So it will take a ton of time in order for that water to catch back up to what they're pulling out. So at the end of the day, they're gonna hit the bottom. They're gonna run out before nature's able to put that water back in. And why should we care? Okay, so if you're watching this on the interwebs, that's really cool. So I teach in North Carolina. I do not live in the Midwest. I have no plans on living in the Midwest. Seems like a nice place, but I like the coast. All right? But I should still care about the Ogallala, all right? Because this resource, we relate it back to this first question, okay? Water's a necessity. Water's needed in order to make food, all right? This agricultural market out yonder in the Midwest, okay, affects us here because this is where we're getting another vital resource from. All right. So let's wrap up by talking about a couple other issues that is associated with overusing groundwater. This one is called subsidence. So remember, sub means under. This happens when land physically sinks due to the removal of groundwater. So imagine having a sponge and then it's all nice and full of water. It's nice and saturated like an aquifer. If you were to squeeze that sponge and remove that water, okay, and you were to compress it, all right, and you were to put weight on the top of the sponge, that sponge would get skinnier, all right? Some subsidence can be very extreme. So this picture, I know it's really hard to tell what is happening here, but this telephone pole looking thing, it has 3 dates: 1977, 55, and 1925. And this guy is there for scale. This shows how much subsidence has happened over the course of 52 years. I think this is in Southern California. But basically in 1925, the ground used to be up here. And obviously this fella, he's probably an average size guy, between 5'8", between 5'8", 5'11", thereabouts. All right, this is almost 30 feet. That's how much groundwater was taken out. All right, and that's a problem. You might be like, okay, what's the problem with the ground sinks? That's really cool. If you're building a road on something, you're not building it with the anticipation that the level is going to change. So this can damage infrastructure, roads, buildings. It can make areas more prone to flooding because you're changing the elevation. It's now lower. Remember, water goes downhill. Water goes to the lowest point. All right, so subsidence can cause a lot of other issues. And our final issues is called saltwater intrusion. This is going to affect our friends out on the coast. All right. In a coastal area, if a well is overused, salt water can be drawn up into a well. So imagine a well, kind of like a straw. Okay, so here's our fresh water. All right. There's always going to be a little bit of salt water, okay, near where the ocean meets the land. As this well sucks up fresh water, it's going to draw this salt water further and further inland. Once you get salt water in a well, it's no longer usable because you can't drink salt water because it'll actually make you very sick because it dehydrates you. You can't water plants with salt water because the same thing would happen. The plants would become dehydrated. You can't use it for agriculture. You can't use it for like household. Like you're like, oh, can I like take a bath in salt water? I mean, you can, but your pipes are going to corrode and like you're not going to have a great day then. All right. So overusing it will bring this salt water in if you're near an ocean. So how do we fix it, okay? Again, I tell my students kind of the theme in environmental science is people mess stuff up, but we can do better. But we can fix problems, okay? Or do our best to fix them. All right, here's a couple ways. Drip irrigation. This is especially true in agriculture. So if you remember that video with the Ogallala, they had those irrigation. They had pivot irrigation, which is where you have these big kind of rigging type setups where water is sprayed down onto the ground. A lot of that water doesn't go to the plants. A lot of it ends up evaporating back into the atmosphere. So it's not very efficient. Drip irrigation involves you taking like pipes or tubes or whatever and running a small amount of water through them and having these little holes where the water can drip right next to the plant. So this way you're using less water and a higher percent of it goes to the plant instead of back to the atmosphere. So it's more efficient. All right. Reduce our daily amount of water that we use for daily activities. So there's a huge discrepancy or a huge discrepancy, the right word? It might be. If you look at like people all around the world, like in different countries, in different places, in different economies, how much water we use. We use a lot. That's kind of one thing good Americans are really good at. We use a lot more than we need. We really could cut back and be okay. Fixing leaks, limiting how much you water outside, particularly during droughts. Okay, whenever there's a drought, you want to be super careful with how much water you're using. Again, the amount of water on Earth isn't changing. It's not always in the same place. So during a drought, if you're using water just to water a lawn, which is not necessarily a required activity. That's not something that you need to do to stay alive or to stay healthy. All right? You can minimize that. Okay. So take a moment, look at these questions. You have an assignment today. If you have any questions, you can leave in the comments, send me an email, whatevskis, and I will see y'all later.